for B, it says relative frequency distribution.
So relative frequency distribution is the table.
I'll call you.
Yeah. Anybody remember the question that's definitely going to be on every test? We told you that yet? Yes. Every single test that I give you will have some variation of the question, what does the z-score tell you? And I still get about 50 to 60% of people get it right. And I'm doing exactly what you always want every teacher to do. Tell me exactly what's going to be on the test, Jeff. And now I'm giving you the exact thing. I still get about 40 to 50% get it wrong. It's like, oh, what does this z-score tell you?
Standard deviation.
The number of standard deviations from the mean
To the data point.
to the data point. I love it. Do you have to say exactly that way? No. Do you have to say exactly those words? Not really. You have to use the word standard deviation for damn sure. But sometimes you guys just throw the words down in this interesting spaghetti of words that you're just like, please, dear God, take this, Jeff. What's more important than memorizing the damn thing is understanding it, right? If you understand it, you will get it right. Yeah. So, I think I showed you this last time, right? Didn't I show you this here? I know we did this one. But didn't we solve this for x? Did we solve this for x? Yes. Remember we multiply by the sigma, and then we add the mu, so we get this. So actually, if you want to, you can go back to your formula. Nobody told me that suggested this. So I'm going to be nice and say you can add this to your formula sheet if you want to. There are a few problems in the homework that you can use this formula that kind of get you used to the idea before they even give you the formula, which sounds mean, but it's the formula just summarizes what you would do anyway. That's all a formula does. It doesn't set it, it just shows you what you would do. So what is this? This is actually a note that I must allow you because it's a formula too. So what's the z-score tell you? The number of standard deviations from the mean to the data point. So math is a foreign language, so if you know how to translate this into English, you won't miss that. So watch this. So the homework has stuff like what data point is 2.17 standard deviations below the mean. And they tell you the mean is 11, and the standard deviation is 1.57. Now watch. So what data point is 2.17 standard deviations below the mean? And the mean is 11, and the standard deviation is 1.57. So even without knowing this crazy formula, I'd go, okay, start at 11, and do I go up or down? Down. That's a trick question. Yeah, below, you go down. Minus 2.17 standard deviations. 2.17 of these. That's the formula, isn't it? The mean. Why is it negative? Because the z-score is negative when it is below, right? So the mean plus z, but that's a negative z-score, times the standard deviation. Okay, maybe. So they didn't even give you this formula, but they ask you this question because you should be able to do it. It's just using numbers in the right way, which is something all humans need to be able to do. So whatever the shit you get there, just throw it in the calculator. I think it's 7.77, just to make something up. I don't know. Is anybody doing this? Nobody's trying that out? Okay.
7.5931.
I got close.
Is this chapter 2?
Yeah. Yeah, chapter 2 is one that introduces standard deviation, all that stuff. This is section 2.7 to be very specific. All right. If you are very far behind in homework, I highly recommend that if you're not going to have time to do every single problem out of every single section, you do some problems out of each section, right? You do to make it really, really dorky, a stratified approach, right? If you have entire sections that you don't do any homework out of, guess what? You're gonna die on those questions on the test. Of course you are, because that's what homework is for, is practice. You don't get practice, you're gonna suck. Same thing happens if you want to play a musical instrument, you want to play a sport. You don't practice, you ain't gonna get no medal. You want to be like Shaun White. Yes?
How is like gas prices not continuous?
Oh, so what's the exact question?
Says the price of gas as listed at
Ah.
a gas station.
As listed at a gas station. As listed, right? So how would they list gas price at a gas station? Tell me, what's gas right now? How much does it cost? Do they ever say $3.49? They say $3.49 and 9 cents. Right? So they actually tell you 3.499. What's the next number up from that would be 3.500. Didn't I skip 3.4991, 3.49992? Yeah, so does it take every value on a continuum? No, it skips. Because it only, as listed on the billboard, it's going to only go out 3 decimal places. So it's going to skip an infinite number of numbers. So really, the next one you'd see would be something like this. Well, so that definitely skips. Yeah. If I just said the price of fill in the blank, that's continuous. Because you could calculate it out to be very, very precise. I like it. I do kind of like giving true-false questions. I never just leave it at true-false. For one thing, I always get somebody trying to give me that. I love that shit. Which one is this? Well, what was the answer? Really?
Which one's right?
So I always say explain. So one way you can explain a true-false question is to give an example. So for the problem, the mean and the mode can never be the same. If you look at my answer, I give you an example. False, 1, 2, 2, 3. The mean is 2 and the mode is 2. So if I ask you that kind of question, you just give me an example. In this case, it's a counter example. You don't have to figure out a paragraph to describe it. You can just give me an example. That'll work sometimes. Let's see, what else can I tell you?
What was the explanation for 6b? Square root of squared? Is that what that says?
It is the square root of a squared number. Yeah. So it definitely can't be negative. Plus, it's supposed to represent how spread out the average distance from the middle, and that can't be negative. I like it. Yes.
Can I ask a homework question?
Of course, yes.
2.490. It's about.
Oh, yeah. Oh, okay. So they give you this here. Number of movies, the frequency. Is that right? Yeah, you can tell. I grade these problems. They start to stick in my head. So how many total things were in this data set? How many total things were in the data set? There's no other way to say that. 25. Yeah, 20. There are 5 that were 0, 9 ones, 6 twos. So how many total? 25. So when you go to calculate your 5-number summary, because this asks you for a box plot, so I have to find the 5-number summary. The low and the high are easy. What's the low? What's the high? Yeah, the lowest is 0. Now these are not data points. These are how many zeros, how many ones. So the lowest data point obviously is 0, and the highest data point is 4. That's crazy. So how do I figure out Q1? Well, I would take what percentage? 25% of 25. Just don't get freaked out that it's the same. 6.25. What does that mean? What do I do with that? So the 7th number would be the answer. Now, what's the 7th number? Well, the 5th number is 0. 6th number is 1. 7th number is 1. Do you guys see how to... You could write it all as 0, 0, 0, 0, 0. 1, 1, 1, 1, 1, 1, 1. Yeah. You could write the whole damn list out, but why? You can count. This gives you a way to count. So this would mean, what was it? The 7th number is 1. So Q1 would be 1. Q2, same idea. Is that cool? Is that all right?
Yeah.
Okay.
But what about the box plot? Using the box plot itself?
All right. So I'm going to have to go from 0 to 4 here, right? So there's the low, there's the high. Where's Q1? It's at 1. Then you put another little slash at Q2, and you put another slash at Q3. Now what's interesting here is what's Q2? It's going to be 25%, not 25, 50% of 25, that's 12 and a half. 13th number. And what's the 13th number? 14th number is 1, so the 13th number is 1. And why is that a little bit freaky? Because Q1 is also 1. So what's that mean? It just means, now the way the book does it, put a little dotted line, but you draw, there it is. You draw a line where it is. And then Q3, I would count in 7 from down here, 5. So it's going to be Q2. And then you make a little box, make little whiskers. I don't know why I did the whole problem for you, but there's a freebie if you haven't done that one yet. Just couldn't stop myself. What's up? Is that? Oh, sure, yeah. Don't get too excited. Somebody's like, it's a problem. Yes.
So for section 2.3, it's number 23 for part B. I don't know, I just didn't understand that.
78th percentile?
Yeah.
So, how many data points? So 78% of 29, yep. 78% of 29 is something. I don't know, you have to do the old calculator. You get some kind of decimal, you round up, and you take that number. That'll be the answer.
Yeah, it's 22.62.
So it's 22.62, so you round up. The 23rd number is the answer.
Yeah.
And you go take that. Now, some of you guys have either found the instruction solution manual, which is sort of like finding your Christmas presents. It seems good at first, and then later you go, well, that wasn't that good. I guess none of you ever had that happen. I did that one time. I thought, oh, that's so cool. And then Christmas morning, I'm like, oh, shit, I know everything. Shit. It sucks. Here, unfortunately, what it means is you don't know shit if you find this solution manager start copying shit down. And sometimes there are typos in it. There are typos in the instruction solution manual, which is nice for me. It makes it easy. And sometimes they have answers based on the book's method, which I didn't show you. I want to see the answers based on the correct method that I showed you. So this is a good example. This one has a different answer for the than what it should be. So be really, really careful. Please, dear God, don't. I'm not. If you're not doing that, you're fine. If you are doing that, you got to stop. Okay. I remember, did I ever tell you the story about the guy that tried to slam my door because he got upset at me? Yeah, I called him out because he had copied it. All was just straight from the instruction solution manual. And he said, no, I Googled it. And I was like, oh my God. Because obviously he Googled it and somebody had posted the answer from the instruction solution manual. But I realized that some students seem to think that homework is like a scavenger hunt. Go find the answer. Where would it? No, it's you do it, so you learn it. It's crazy, right? It's sort of like walking to the mall instead of driving when you're in driver's ed. What? So I think my bigger theory is like since Google exists, you guys seem to think that everything's been done. I just got to go find it, and you're not understanding that you need to go through it yourself to become more of who you should be. I mean, that's the whole idea. Not let somebody else do it for you. Doesn't make any sense. Anyway, I'll stop. It just kind of gets to me sometimes. Yes?
Can you explain 4B on the purchase test?
Oh, 4B? Oh, all right. So if I don't say, I definitely don't mean Kelvin, because some of you guys don't even know Kelvin temperature scale. So if I said the temperature is 56 degrees, I'm more than likely talking Fahrenheit. Do you guys know how hot that would be in Celsius? I mean, 22 degrees is like 80. 20 degrees Celsius is like 80-something Fahrenheit. So 56 degrees Celsius would be like melting people. Maybe not that. Pretty damn hot. So it doesn't matter even if you get that confused. Does 0 mean what it's supposed to mean, for example? Does 0 mean the absence of what temperature measures? Does 0 mean the absence of what? Think before answering.
No, but it can be negative.
Not just because it can be negative, but because you can lose more heat. 0 doesn't mean the absence of heat. That's the important thing. Profit can be negative, but 0 means the absence of money coming in. So that's why that's ratio scale. But temperature, 0 is in the wrong place. Except for Kelvin. 0 Kelvin means everybody's dead. There's no energy. All right, so the short answer to that is that's not ratio, but it's definitely a number, so what's it got to be? It's got to be interval, and subtraction makes sense, because like if it's 60 tomorrow, that's 4 degrees warmer, right? Differences make sense, but since 0 is in the wrong place, ratios don't make sense. What's twice as hot as 0 degrees? Not 0 degrees. So, do you see what I'm saying? So since 0 is in the wrong place, it throws all the divisions off. That's why those two things go together for ratio. If 0 is in the right place, then your ratios make sense. Is that cool? So ratio has those two things. 0 means the absence of whatever it is that you're measuring, and the division of two data points makes sense. Those two things have to happen. If one of them doesn't happen, it's not ratio. I like it. And don't tell me that it's ratio because you can take an average. No, I can take an average of a lot of shit. That's not. I can find an average temperature. Doesn't make temperature ratio. You have to divide two data points and have the answer make sense.
Can you explain 5 a little more?
Oh, so I gave a couple examples in class. The two main examples I gave were, we live in San Diego, so where would there be extreme highs of something that's measured in San Diego? Okay.
Temperature in the desert.
Sure.
But not right now.
Not right now. Where would there be... All right, let me just say, we talked about home prices. Aren't there extreme high home prices here? Right? Yeah. You go walk around La Jolla, you're like, there's some place I'll never live. There's another place I'll never live. But they're beautiful to look at, right? What the shit? Why not? And also, the one I did on the board was like income. Right? You have 4 people and then a CEO. The CEO could be making way more. It's going to throw the average way off. So you'd rather use the median in that case. So when you have outliers, when you have outliers, you want to use the median instead of the mean, because the median is not affected by outliers. Okay. Yes, ma'am. Okay, so there is a method using the interquartile range that I don't really talk too much about because it's not really used that much, because we're going to develop a much more robust way to do it with the mean and the standard deviation. I think I already said, like, haven't I said this already? 2 standard deviations away is where unusual starts. Because in a normal distribution, what percentage is within 2? 95%. So what percentage is outside? 5%. And if I said there's a 5% chance of something happening, wouldn't that mean it would be unusual if it did? It's a 5% chance that a meteorite's going to, boom, holy shit. That would be unusual, right? Okay. So that's a more robust. There's I think a few people did something in the homework related to the interquartile range, and that's fine. I'm not even going to talk about it. It's not used very much, to be honest. But it's the up and down 1.5 times the interquartile range. But it's just like doing up and down so many standard deviations from the mean. It's sort of the same idea, except it's using median in interquartile range. Don't worry about that. So right now, all we know is if your z-score for your test or something was 3, you have an unusually high test score, right? Because you're more than 2 standard deviations away. Or if your height had a z-score of negative 2.5, that would mean you're unusually short, right? So that would be an outlier. Why do I say it like that? Because it always reminds me of Children of Corn. Outlander. You never seen that movie? No. You're like, if it was made before 2000, Jeff, it doesn't exist. All right, fine. You miss out on a lot of good shit. All we got there are the prequels. I mean, it sucks. What's up, you guys? Anything else you want to look at, talk about? Anything? How are you guys doing? Are you guys doing all right? I mean, what do you think so far? I mean, is this what you expected statistics to be, or what did you expect it to be?
Easy.
Oh, I see. It's like when I taught astronomy and people got upset at me because they thought it was just going to be us going outside and saying, "Look, it's the Big Dipper." There's a lot more to astronomy, so there is a lot more to astronomy.
What is astronomy?
Astronomy.
Oh my goodness. That's cute. No, I know what it is. I didn't know you teach it.
Oh, okay, yeah. My first degree was physics.
You should like do 100 points extra credit if you come to class every day.
On a scale of 1 billion points? No. I should do something for you doing something you should do anyway. Now I sound like my dad, and I don't care. It's an appropriate time. How about you get a higher grade because you come to class every time? Automatic. No. It's just adding up the frequencies anyway, but I don't know.
So for the mean, I didn't round up, and I was off by a little.
You have to truly round. Because being a 1 here is kind of actually, believe it or not, it's getting to be kind of a big difference from 0. I know it's hard to believe, but it really shouldn't be more than like 0.9 or something. Yeah. So this was 45.666. You got to truly round it. Yeah. The standard deviation probably still came out close. It might even come out perfect. Yeah, but still, in general, that's not good because it might take it far off.